Hello, everyone. Thank you for joining us uh, on this webinar all about your sidecars with NGINX and Traceable. My name is Dan Gordon, and I lead the technical evangelism team at Traceable AI. And I'm happy to be your host today. We've got some great content, but before we get started, we have a couple of housekeeping items. First, today's session is being recorded and will be available for replay through this BrightTalk platform. Second, we welcome questions. In the webinar control panel, if you click the QA button and enter your questions there, we will be able to answer them. We can do that. You can do that as we do the presentation as well. Towards the end of the session, we will also do Q&A. If we don't get to your question before we have to end the session, we will follow up with you afterwards. With that said, I will turn it over to Sudeep and Damien.
Good morning, good afternoon, good evening to all of you. Thanks for joining the webinar. We have NGINX and Traceable talking about Kubernetes security and all about your sidecars in this session. I'm Sudeep Padiyar. I'm one of the product management leaders here at Traceable. Joined the company 4 months ago, was at Palo Alto Networks prior to that, looking at cloud and container security. So very excited to work on API security here at Traceable. Prior to product management, I was in engineering management and leadership roles in Cisco.
And hi, I'm Damien Curry. I am a technical director for the Community Alliances team at NGINX, which is now part of F5, and been with the company for and going on 6 years now, and long time DevOps operations sysadmin background.
Thanks, Damien. So we have a packed agenda. We're going to start with about the companies, Traceable and NGINX. Then we'll get into API security, Kubernetes, and a lot of interesting topics. So to start off with about Traceable, we were founded in 2019. Our founders are Jyoti Bansal and Sanjay Nagaraj, both of who come from App Dynamics. Jyoti is also the founder CEO of Harness. We have a very talented and diverse set of engineers, product, marketing, and sales teams from various DevOps as well as security companies. We are starting off focusing on API security, and that is how we are working with NGINX for better securing your environments, whether it's with Kubernetes Ingress Controller or with the native load balancers.
Yeah, and I'm sure NGINX is a name most people have heard. NGINX was founded back in the early 2000s to solve some, technical issues with Apache, get better throughput, lighter weight, all those fun things. And since then, as of actually just recently, NGINX is now the #1 web server on the internet. So chances are you're already talking to an NGINX server somewhere on the background right now. We since created a commercial version. We came out with NGINX Plus, and then most recently we were acquired by F5, and now we're just spending more time building solutions, looking at microservices, and how we can help and be a big part of the Kubernetes community.
Yeah, thanks, Damien. So let's jump right in. So I wanted to talk about API security, the relevance now, all the different aspects which it entails. So let's start about some of the fun facts about APIs today. So we had a couple of interesting questions. I'll start off with, what is the single most frequent attack vector for 2022? So obviously we've heard a lot about ransomware these days, with what happened with the attack in the pipeline at JBS Foods, and then more recently last weekend with KCR Software. Similarly for phishing, with the pandemic, there has been a lot of emphasis on email or SMS-based phishing, and insider threats, unfortunately has always been on the top. But interestingly, the answer to this question is neither of them. It's actually API abuse, based on a research which Gartner had done in 2019 as well as in 2021. Consistently, API abuse happens to be on the top of the list. Another interesting fact around the percentage of web traffic today, which is API based. Again, we have four numbers. They're ranging from 33 to 95. So the answer actually happens to be 83%, right? And this is based on a study which Akamai, being a leading CDN vendor, has a lot of access to that data. And this is from 2020, right? So given the pandemic and most people working from home, this is probably closer to 95% now. So
Yeah,
that just
it's
shows you how prevalent API usage has been.
Yeah, especially as more, everything gets broken apart and we have different vendors and software as a service and all the different platforms. There's more and more communication or APIs, even if it's part of your, internal application infrastructure, they're still traveling across the public internet, and it has more and more endpoints that can be exposed for those attack vectors, especially as, like you say, there's more authentication endpoints, easier ways to trick people. It's just a very, very wide open space for attack.
Yeah, and interestingly, if you look at the evolution of security from malware-based threats, now everything is moving to stolen credentials or API compromises or business logic attacks. So that shift has happened in the last 3 to 5 years. So having said that, if you look at some of the recent API attacks, whether it is Facebook or Apple or Nissan, Shopify, the list is pretty long, but they are all based on API specific threats, which have been leveraged by attackers, right? In case of Facebook, it was actually an access token, which was harvested. For T-Mobile, it was a leaky API. For Shopify, there were other mechanisms used, which were more like around BOLA and things. Now, the interesting fact here is that a lot of these are, heavy-duty tech companies which have very large security teams, right? They have product security engineers, they have InfoSec, they have DevSecOps, and still we see a lot of these attacks going through. So if you then look at regular enterprise companies which don't have such large teams, you can clearly tell that the need for API security is very high, because you actually need to have a more of a product-based approach, more emphasis on best practices that your developers need to take some of the onus on, in addition to the stretched security teams. So all of these different aspects, make API security more and more relevant, given the adoption of cloud-native applications. So moving in, just like network security has evolved over a period of time, things started off with firewalls, right? So application security in the early days in the 90s was tied to firewalls. Now, over a period of time, they added more intelligence around next-gen firewalls, which were application aware. So from layer 3 to layer 4, there is some visibility on layer 7, but that's where it stops, right? So a next-gen firewall can tell you today that, hey, the traffic is web browsing, or it is Redis or Mongo, but that's where it stops. There is no visibility into the API flows or understanding how risky some of these APIs can be, or how they can be compromised. So that is where the Gen 1 app security kind of stopped, leading to WAF, RASP, and other technologies. Now, WAFs are very useful when you put them in the front with the cloud load balancers, for instance, but they do have their limitations when it comes to not having comprehensive blocking functionality or alert fatigue, because essentially they're sitting outside the application, so they do not really know which application they are protecting and the vulnerabilities associated with it, right? So not having the API or the application context inherently causes some limitations in some of the Gen 2 technologies. RASP has tried to solve that by being closer to the application, but again, they don't necessarily have visibility into the API flow or the logic as your users and applications are exercised by different application flows. So that really brings us to the Gen 3 security and what is actually needed in this area. So if you look at it, attacks are now happening at the API layer. So Gen 3 app security needs to actually understand the API inventory, right? Which APIs are risky, which ones are constantly changing, or which ones attackers are trying to access more frequently with incorrect parameters, or if you look at the OWASP API top 10, if you look at broken object level authorization or mass assignment, these are the techniques which the attackers are using, and that is where the focus needs to be. The second key aspect here is that it should be more learning based, because APIs and applications are changing very frequently with the rise of CI/CD and cloud native applications. Releases which used to be weekly are now daily or hourly. So that means that if you had static rules, or if you are actually trying to bring in security statically, that's actually not going to work in this environment, right? So learning, whether it's machine learning, artificial intelligence, baselining of application behavior or user behavior, all of these aspects become very important. The third thing is around data flow and the risk, right? So especially if you look at sensitive data and how it flows within the different APIs, which of them are accessible externally versus internally, all of these aspects are something which the Gen 3 application security needs to encompass. So again, to summarize, they need to be API centric. We spoke about learning, user behavior, and how easily you can integrate this into DevSecOps also becomes very important.
Yeah, and those are really some of the key places, is especially with that API traffic. There's a big difference where a API call from one user may be completely normal, but for a different user, it's a huge red flag. But that's not a level of logic that's easy to pick up at that WAF level. And it's also not something that you can program, right? It's all about looking at behaviors and learning, and not just trying to define it and guessing how somebody is going to try to compromise your system. You need to be looking back at how are people actually using the system, and what does it mean when something looks out of place.
Yeah, so that again brings us to an interesting point around how security needs to be layered in the cloud native application or the API world, right? As in, if you look at our common deployments, they are typically in the public cloud or private cloud, where certain onus of security, especially for the infrastructure security, is now on the cloud providers, right? As in, if you look at security groups, which AWS provides, they give you that basic infrastructure level security. So you will then look at workload security on top of that, right? In the context of what we will cover in the rest of this webinar, it's primarily around Kubernetes, right? So workload security around containers, network security, which say comes from Kubernetes network policies, right? How will you use that in conjunction with what you do at the NGINX Ingress Controller? Similarly, API security is a layer above this, but all of these different components of your application are now accessible via APIs. So this layered approach for security becomes extremely important as you use different parts in building your applications, right? As in this case, for Kubernetes being front-ended with NGINX Ingress Controller, this is where both our companies decided to put some thought and energy behind how to actually secure Kubernetes more effectively using our technologies. So that's how a lot of these security needs and requirements are evolving over time.
Yeah, and it's a lot around that. I think that's the main thing, is it's all about that layered approach. There's no one single approach or solution that is a end-to-end security solution. It's all about having the different layers of security that work together to combine and really provide that level of security that you need in this day and age.
Yeah, so though it's an oft-repeated word, defense in depth continues to be, as relevant today as it was in the past. It's just that some of the layers, whether it was network security or endpoint security, is now evolving into API security, workload security, and then the infrastructure security. So defense in depth is definitely something which is very relevant in these environments. So let's jump right into the Kubernetes, the cloud native architectures, and then look at how to secure it. So over to you, Damien.
Yeah, thanks. Yeah, so I mean, when it comes to Kubernetes, it's like everything else. It's adding a whole new set of problems and solutions, right? So can we bring up that next app there or the next slide? One of the biggest things that Kubernetes has really been doing is really pushing that move to microservices. It's something that we've been talking about for a very long time, and just like Kubernetes, we've been talking about it for a long time, but we're now finally really seeing that shift into production. And once you are moving towards that actual production of containerization, there's a lot more different solutions that you need to come up with. So it's while they can solve a lot of problems and implemented properly, microservices and Kubernetes and this modern application architecture can provide you a very, very resilient platform and application. It also does come with its own set of challenges and complications that come up in that environment. So one of the other things we asked when we did our surveys, we were asking about what are the challenges and what are the biggest problems and things people run into when they're on this journey in microservices and Kubernetes. And one of the biggest things we find it's people are very worried about complexity. So we can see with the graph we have on this next slide here, um, there is the number one call out is complexity. There's a lot of moving pieces. It can be very, very scary for people who are used to more, monolithic applications or, the very traditional high availability and scaling out that way, where you were more pre-provisioning and going, okay, well, I'm expecting this level of traffic so I can pre-provision everything. And now we're in a world of, well, we can scale out. It's all about build once, deploy everywhere. And it can look very complex, and it is complex. But once you get past that hump of getting it architected and built out, now you're in a situation where you're able to, instead of having to do all that pre-provisioning, you're able to scale and you're able to easily deploy in different environments globally and have that solution. Um, and then again, that kind of goes hand in hand with the second issue that people are running into, which is just challenges with development. It's a much different culture and way of doing things when you really embrace the whole CI/CD, DevOps, Kubernetes, modern application architecture. And then, strangely enough, or unsurprisingly, you'll see number three is security. There's a lot more moving pieces. It's a lot of new tech, and people are worried. There's just new emerging things every day. You're dealing with a lot of open source projects that gives a lot of people heartburn. Um, and then there's a lot of other ones that are all kind of specking out there. There's just training, trying to find people who are up to speed on this. The networking is a whole new space. And yeah, there's a whole lot going on. But what we're really trying to do here is at the end of the day, make things simpler for everybody and really trying to provide that more secure and scalable infrastructure. All right, yeah, and these are and I think really what we're coming on is these are the biggest challenges, but they're also the biggest benefits, right? It seems very difficult to scale Kubernetes until you can kind of step back and look at it as you can now develop a kind of dedicated cluster. So when it comes to scaling, you're just adding more. You're not having to necessarily scale out. You can think of it as a more modular approach. And then again with security, because you have everything's driven by APIs. So you have to think about not only how are you securing your applications and the APIs that are being consumed by your applications or by your end users, but you also have to think about how do you secure your infrastructure. You have to expose your Kubernetes endpoints to a certain extent, but if somebody gets a hold of your Kubernetes problem, they can wreak a whole lot of havoc in your environment. So there's multiple layers of security where these are things we have to think of. And then the last one really is the visibility and insight. How do you take all of this information and how do you troubleshoot when you're dealing with very ephemeral instances, when things are just going away and coming back, and you have infrastructure spread out everywhere? And we're kind of getting to this point in the industry where we've gone from being, just scrambling to get any information from monitoring and metrics and just trying to get any little bits and pieces of information, where now we have this, these traces that run throughout from one end to the other of this infrastructure. Now we're kind of dealing with the opposite problem of how do you filter out all this noise and get actual valuable information that you care about. And so it's kind of a double-edged sword there, where you get the benefit of having a ton more visibility, but you have to figure out how to do it, what to do with it. And then, the next thing that really comes up here is that's to run a cluster. Now what happens when you're trying to run this at scale? When we come to the next slide here, there's kind of two major issues that we look at when it comes to running Kubernetes at scale. And that's mainly the complex applications. Is how do you provide the capabilities that these more complex applications required, especially when you're looking at either migrating more legacy applications into a containerized and Kubernetes environment, or if you're just building something that maybe doesn't fit in the confines of the functionality that comes out of the box with a lot of these products. So how do you figure that out, and how do you balance that without putting all of the onus of putting that complexity into your application rather than offloading it at the more infrastructure layer? Um, and then also one of the other big things here, and one of the things that Kubernetes is supposed to help with, is multi-tenancy. How do you share this infrastructure? Because one of the huge benefits about Kubernetes is this self-service model and being able to empower different teams to deploy their own containers, to manage their own infrastructure, and to control their own applications. But then you also have to look at how do you allow people to do this without running into, the noisy neighbor problems. What happens now? You have a developer who, maybe they just thought they were breaking their dev environment, but they didn't realize the implications that puts on all the other nodes in that cluster. So there's a lot going on, and a lot of what we've been focusing on with at NGINX here is our ingress controller for Kubernetes, where we can kind of dive into that a little bit more, because we really looked out to trying to solve these problems here. So if we can jump
Damon,
on,
interestingly,
yeah,
when you bring up multi-tenancy, an interesting experience from a lot of our early customers has been around, something very similar is around the APIs, right? As in,
yeah,
they are in staging or production, pre-production. Some of these are changing. How can you actually have an understanding when they, traverse these phases, as well as when they come from different lines of business? How do we keep track of that, right? So we've been looking at different ways to solve it. We then ended up introducing a concept called environment, so that the API developers can actually keep track of their APIs around different environments. So it's good to see the commonality here,
yeah,
as in what you see in Kubernetes is then applicable to upstream,
definitely.
where different APIs end up using that infrastructure.
Yeah, it really is one of those the downside of the microservices, right? Because you have multiple teams, and you got to
Correct.
make sure you're locked onto the right version, because all of a sudden the other team revs their app and now your app breaks and you have no idea why. So it's it's a very important and often overlooked, honestly. I mean, everybody tends to kind of develop in a silo sometimes, and then all of a sudden they go, wait, why'd that break? And it's something totally unrelated, but they're all tied together now.
Correct. Correct. And that's where things around API versioning, security, all of these are areas which we are trying to focus on, so that customers both have that visibility as well as they can account for it whenever these changes happen.
Definitely. Okay, great. Yeah, so we'll just dig right into the ingress controller. So I'm sure there's a lot of people where the as we usually refer to the upstream ingress controller, what comes in by default from Kubernetes is based on NGINX open source. When Kubernetes started picking up steam and we were looking at it from NGINX side of things, we wanted to build an ingress controller that we were able to support and build in our advanced features that we have in our enterprise products. So we ended up building our own ingress controller implementation. And we tend to refer to it as more the production grade Kubernetes components. So this is a diagram we've been using a lot to help explain what we mean when we talk about this modern application architecture and what it actually looks like when you're dealing with these microservice and the CI/CD pipeline, and to try to help explain some of the complexity. And so really the whole thing here is it's all about application or infrastructure as code, application as code. Everything is driven through a code repo. Everything runs through a CI/CD pipeline and automation, and that really just frees you up to have that pipeline so you're not worrying about your deployments. And we have built-in functionality above and beyond what is in the open source one to allow some better processes. And especially when we've introduced our NGINX App Protect, which is advanced web application firewall. Now, not to be discouraged earlier from us talking about how there are shortcomings of WAFs, but there are, and this is exactly one of those great examples of this is how you can provide that layered security solution and provide that different layer. So if you actually hop onto the next slide there, we can see that we have a fully integrated ingress controller with a WAF that is natively built into Kubernetes, easily integrates with all of the CI/CD pipeline tools. Basically anything that integrates with Kubernetes, it's really easy to manage. This is a really interesting way of doing it too, where a lot of the times we'll talk to people and they, you always think of a WAF as the thing that's, sitting at the very edge of your infrastructure and coming in, and you do that scanning there, and then, well, it's all safe, so we're internal. And really the way we've been looking at this now is you have such varied applications, there's usually no need to apply all of the security rules to all of your applications, and you can save resources. So a lot of times what we see more and more people doing is it lets you go ahead and have more your general WAF layer at the very edge that is doing your OWASP top 10, that basic rules. Then as you get closer to the infrastructure, you're able to have NGINX App Protect running at the ingress controller layer, only being applied to the pods that need that specific level of security. So it really allows you to have that freedom to be more tailored. So you're not having to apply the same security policies for a web app as you do an API. And then you're even able to dig in even deeper there and get that other modularity and add on extra layers of security that are even more API aware as it goes into that through that infrastructure. And we'll get into the next section. We can start talking about a little bit of what we've done with our ingress controller that allows us to really do these integrations a lot easier. So one of the things we were really seeing in the ingress controller space is that it solved a lot of problems, but it didn't allow you to have the full rich capabilities of what is possible in NGINX and NGINX Plus. So we went about and built our own implementation of what we refer to as virtual server and virtual server routes. And this just allows you to have more granular control over your traffic. It allows you to have more of that complete NGINX configuration access that a lot of the users are used to, and even allows you to have policies. So you can have a policy that is set that defines rules that need to be applied to all of the different resources. So if you have that multi-tenancy, you can have your SecOps team define that level of security that all ingress needs, and then you can easily apply it. So it's much easier to manage. You're taking the onus off of the application team, and again, just making it easier for them. And as you can see, we have App Protect, and we also have the ability to enable things like Traceable in their module, at these different levels. So just because you're using Traceable in your environment on the Ingress controller, it doesn't have to be running on every endpoint if it doesn't need to. So it just really gives you that flexibility, and really just being able to do things like the split traffic and matching traffic. So you're able to do really intelligent blue, green, and canary deployments automatically in Kubernetes native. So it makes it really easy for that CI/CD pipeline to have that fully tested, fully automated rollout process where you're really able to test things end to end as they come along. So those are some of the main reasons that we've done here, and that allows us to kind of access these use cases that maybe aren't necessarily available in some of the open source policies. So when we look at things like on the next slide, we have it kind of broken down with some of it with things like conditional routing. So you're able to route based on different information in the request. You can multiple clients, you can have multiple versions, very easy to split it up. Again, A/B testing, being able to do split routing, able to implement custom error pages and functionality so that you're be able to do real circuit breaker failure patterns and really stop any failures before they get too far in your system. You're also able to do rate limiting. You're able to offload authentication at the Ingress controller layer. Again, you're able to do the WAF at the Ingress controller layer. And even, we have the ability to do more fine-grained, easier to control snippets. So when you do run into situations where you need to do something that isn't even covered by the more advanced functionalities we have built in, it leaves you a way to be able to really just insert whatever you need to. And this is actually one of the things we leveraged to make the traceable integration easier to implement and handle. So finally, just do a quick slide on just highlighting some of the differences. Again, we just have more production grade, focused on the features and functionality that we've heard from customers of what they need, fully supported. And one of the biggest ones is it's continual production readiness. We have the stability. We do not make backwards compatible breaking changes. The code bases are integrated with native NGINX. There's a much better patching plan from us because it's not as many layers of people who need to patch CVs or things like that. So there's a lot of really interesting stuff happening in this space. So now, I guess let's finally get into it. Why are we both talking here today, right?
Yeah, thanks, Damien. And a lot of the things that we went over so far is actually what necessitated the technical as well as business partnership with NGINX. Essentially, a lot of the requests coming from customers, where they're using an ingress controller at the front of the Kubernetes cluster. They need API security, and they need a more efficient way by which both these technologies can be used in their environment. So that actually got us thinking and working together on this. So at a very high level, I'll go over the different components which are part of the Traceable and NGINX Ingress Controller solution. So you will typically have a customer environment, whether it is in an AWS or Google GCP VPC or on-prem. You have your Kubernetes clusters, which are managed or unmanaged, could be EKS, or could be something which the customer stood up themselves. And then you have different services where the application pods are running, right? So everything is as usual for the DevOps and application teams. Your NGINX Ingress Controller is now taking care of all the traffic going in and out of your clusters, as well as routing it to the right services. So now we seamlessly bring in a plugin, and we'll talk about how we install it, but it's essentially a plugin which runs in the context of the NGINX Ingress Controller with the integration points that Damien just went over. From the traceable perspective, we use it for data collection, right? So for the spans, for the traces, as the data goes in and out of the ingress controller, that's where we need that insertion point. So we collect all the data from the plugins. We have a lightweight traceable agent. which essentially aggregates data coming from multiple such plugins, which can be used for local processing, which can be used for sensitive data redaction. We have customers who don't want sensitive data to go to their SaaS platform, or they might choose to process everything locally. We give all of those options to our customers, as well as any local rules that need to be applied. So all of that is done by the Traceable agent. And then we have our full-fledged, traceable SaaS platform, where all the machine learning happens, where we look at data coming from multiple users, multiple API endpoints, and then all the decisions are done there. And then if there is a blocking based on our machine learning, then that is relayed back down via the traceable agent and plugin. So that's how the integration is working in terms of the logical blocks.
Yeah.
Damon, if you want to add
And
something there.
yeah, I mean, the best part of this is because it is a module that gets loaded into NGINX at runtime. Not only are you able to easily apply it in this sort of scenario, you can also take this same logic and run it wherever you run NGINX. But especially when it comes to Kubernetes, it's being able to load it at that Ingress controller layer and cut down unnecessary extra hops. You're not adding in extra overhead for another node that all traffic needs to get routed through, or you're not trying to set something in front of the cluster and route traffic through that. You're really able to target the traffic that you care about and not having to re-architect your entire system to do it. It's really a great architectural way of handling it.
And that worked really well for us. Actually, in a couple of
Yeah.
days, our developers were able to get all of this working. So the integration points are very well defined. You can use your regular Kubernetes tooling with Helm and config maps and YAML modifications. So everything that you see here is a native way of deploying Kubernetes.
Yeah, and you can see this is the config that was needed. So this is put in as a config back that they're pushing through into those virtual server routes, and you can see how straightforward it is. Minimal changes. Now, I believe, if I remember correctly, this is turning it on globally. So with this config, it would just run the tracing on any ingress resource, but you're also able to be much more specific about it. But it's really interesting to see how simple this was versus the implementation for the upstream ingress controller, where it necessitated custom CRDs and a lot of stuff. Now, I don't want to gloss over the fact that we are custom building an ingress controller image with this module baked in. But outside of that, we really are doing minimal modification to the infrastructure.
Yeah, and everything is plugged in these config maps, whether it's the policy agent that we need, or the tracing components with open tracing. All of those modules are, that's the only thing that you need to add into your config maps, and you're good to go. So all of this is very easy for developers or DevOps to bring in when they are doing their push into staging or pre-prod, so that everything is done with your regular tooling for Kubernetes. So at the end of it, this is how it looks, right? And this is actually a snapshot of our application flow within the traceable product. So NGINX is right up in front because we detect that being one of the services within Kubernetes. So the NGINX controller is what will be the external interface point. So all of the APIs which are exposed outside of the Kubernetes cluster will go via NGINX Ingress. So as you can see, for all the different services which are part of this application, the traffic going in and out of the cluster will go via NGINX Ingress Controller. So that makes it very easy, and also gives the security operators the confidence that any traffic which is going in and out, which needs security, can be seamlessly secured by the modules that you saw in the prior picture, right? So that's a very easy way by which security enforcement can be done without having to worry about which node or which daemon set the applications are running in. There is a very easy mechanism to ensure that the security is baked into the application itself. Now that we went over how Traceable and NGINX can help you protect your Kubernetes environments, let's look at Traceable as a product and technology on how it can protect your APIs in a little more detail. So the approach that we brought in for API security is centered around three main aspects, right? One is visibility. So as the age-old saying in security goes, you cannot protect what you cannot see. So the first thing that we focused on in the product was to give you an ability to have continuous API discovery so that as your developers are building new APIs or they use third-party APIs, the product gives you visibility into that right away. The second aspect is around risk, and we do that by looking at all the different aspects that are part of the API, right? Whether it's an external API, whether it is authenticated or not. So based on a bunch of criteria which are tied to API risk and health, we give you a very good assessment. So that will help your developers as well as security teams figure out what additional changes need to be done. Observability is something which gives you an end-to-end view of how the applications are traversed, how the APIs are connected, the API flows. So all of this gives you very rich visibility into the APIs. Now, when it comes to protection, as we said earlier, with the WAF and RASP, there are some inadequacies which make it inefficient in an ever-changing DevOps world. So we give you, pretty much the next generation version of these. And we do that by being AI and ML first, right? So when it comes to anomaly detection, when it comes to baseline behavior, we are constantly learning both the anatomy of the application with regards to all the different components on the API side, like I was mentioning earlier, but also on how the users, whether they are manual users or bots or other automated mechanisms by which these APIs are accessed, by constantly learning, what each of these are doing with the application flows. So because we are AI first, it means that no rules are required, but if you choose to have them to have parity with your traditional WAFs, then we allow that. And a direct result of this is that there are very low false positives, and the alert fatigue that is associated with some of the older technologies is automatically taken care of. Now, because we are ML based and we are collecting a lot of data from your applications, we can do a lot of interesting use cases with that data. A couple of them are threat hunting. So we actually can now go and figure out how these different malicious and threat actors have been traversing through your systems to give you views into, did they access sensitive data? What were they actually doing when they were lurking in your environment? So we give you a lot of those threat hunting as well as forensic features. And because of all of this rich data and the traversal information, you can now easily use this for compliance and auditing purposes. The foundation of all of this is our distributed tracing platform, because we are one of the few companies which have taken the tracing technology, and because of all the capabilities it has with being able to track user and application flows over a period of time, we are now using it for security. So the distributed tracing platform becomes the foundation of all the components that I covered here. So next, let's look at how the different components come together. Again, you will see a lot of this in the demo, so in the interest of time, I'll keep it brief. But as you can see here, once the user performs all the different actions, we are tracking the user activities. So based on the identity, which we get from multiple sources, we also look at the roles and permissions of what they can or cannot access. So this gives us a very good view of how the users are supposed to traverse the application. Similarly, on the API side, like I was mentioning earlier, the edge versus internal is a good determination which is needed from the security perspective. Similarly, the sequence of API calls over time from good versus bad actors is also something that we are constantly learning. So what that gives you is essentially, data flow for sensitive data, for actually figuring it out that how your applications are accessing different data sources and how they are flowing between your application before it hits the edge of the application flow. So before we get into the demo, I just wanted to explain how all of this is built. So like I've been indicating, the AI behavioral engine relies on a lot of different data sources. We have agents and modules which hook directly into your applications, whether it's in NGINX or within the language or in Kubernetes or Envoy. So all of that rich data, as well as the deployment and code changes as they happen over a period of time from your DevOps processes, gives us all the baseline information to be able to then track user activity, API activity, or the data flow. And as a result of this, you will get all the rich application context, which we use for determining the different behaviors, right? So whether it's on the API aspect or the user behavior, how the data is being accessed, or all the way to user trust, as well as the risk posture. And you will see a lot of these components as we go through the demo. So now that we went over all the different aspects of our integration of Traceable with NGINX Ingress Controller, let's actually see a live demo. So this is the Traceable product, right? So if you look at how we function here, as in we start understanding the different aspects of the application, once your agents are installed, either in-app or in this case, within the NGINX Ingress Controller. So the application that you're seeing right now with the flow map is actually running on Kubernetes, right? So if you look at all the different components that are part of this application, you will see there's a checkout service, there's a data service, there's a front-end service. So these are all the components which constitute the application. And if you look at Traceable, then Traceable has automatically learned all of these components based on the application traffic flow. So like we were saying earlier, because we are based off of tracing and all the components which are part of the application traces as the traffic goes through the different services are understood by the platform, this is automatically built based on the learning. So let's look at all the different components here, right? So because we have been integrated with the NGINX controller and that is front-ending the application, you actually see that within the application flow. So what you're seeing here is the application flow, which tells you very clearly that these are all the different services which are part of your application, and this is the interconnectivity between them, right? So your NGINX Ingress is then followed by a front-end service, and then all the different services that we saw here, which were part of the Trace Shop application, are actually accessible within the product itself, right? So the first layer that you would look at would be the application flow, and then you would have the different services, which you will then start zooming into, right? So if you then look at add service, then the first thing you will notice is because of the tracing information that we have, you can get a lot of information about the call graphs, the latency, the error per second. So that gives you a good view of how healthy that particular service is. So next, let's look at what are the different endpoints which constitute that service, right? So these are the different endpoints, and you can then get into individual events as well as traces as you start looking into that in detail. So the key component of the APIs is what is called as an API endpoint, right? So that is the endpoint which will be hit either by the user from the web browsers or from mobile phones or directly with API access. So if you look at the important ones here, if you look at get product ID, right, you can tell that that's one of the endpoints which are used pretty frequently. I will actually go to 1 month's data so that there is richer data for the comparisons. So you can see the average latency. You can also now start looking at all the different events as well as status codes, which again give you a good indication of how healthy that service actually is. Now, the important aspect when it comes to security is all the security events, right? And now this is where it starts getting interesting, because a lot of the components around machine learning, around how we actually learn about threat actors, how we correlate all the different events as the benign and threat actors actually go through the application, is understood in more detail, right? So that is a very good view for per API endpoint. What are all the different security events? And we'll zoom into this in a second. The key aspect that I wanted to go over was on the DNA, right? Now, for any developer, as well as for a security analyst, it's very important to know that for all the different APIs within their application, how safe they are, or what is the risk associated with each of them, right? So the risk score is actually a very good gauge for determining that. So if you look at some of the components which go into the risk score, then the first aspect is external or internal, right? So as we all know, the external APIs are directly accessible, either they are behind a load balancer or an ingress controller or an API gateway. So there is data which will flow out of that endpoint, which will directly go to users or go to the other applications, such as a partner application, right? So that means that the security relevance is higher on these kind of APIs, right? So that is the first aspect which goes into it. The second is around authentication, right? So whether it is basic or OAuth 2, all of that will determine your overall risk score. So obviously, if it is an external API or it is an API which has access to sensitive data, then we want it to be authenticated and have more controls around it, right? So that is one key aspect which goes into your risk score. The other is around what we call as impact, right? As in, if you look at what kind of parameters does this request contain, right? That means that if there is a breach, then the impact is higher, right? Has the developer or the security analyst tagged them as critical, right? So if they know that this is critical because it is accessing a lot of key components of your application, then that goes into the risk score, as well as sensitive data, right? So we are very unique in the way that we can tell you different details around what kind of sensitive data the application and the APIs are actually accessing, right? So if you go into this view, you will see that there are different data types which are part of the request, as well as what is part of the response. And you can now individually go through that. If you know for a fact that something is sensitive, then you can mark it as sensitive. So you have all the different capabilities by which you can actually say, this is sensitive for this reason, right? So in this case, if we go to the common sensitive data types for the US, we can go, is it a driver's license number, or is it part of the passport or SSN? So you can actually start marking sensitive data right within the individual parameters. So this will actually give you both an ability to redact that when it goes into our SaaS platform, as well as a sensitive data view for that particular API endpoint, right? So that is another key metric which goes into the risk score. So that's how you will traverse the API endpoints. You will look at all the different components within it, and based on the risk score, as well as the threat index, you get a very good gauge for what kind of compromises can potentially happen on these APIs. That also allows your developers to prioritize, which specific endpoints they should pay more attention to for better security. You can search this by tags. So, obviously, if you want to look at critical or external APIs, you can start searching based on that. You can look at the associated risk. Typically, if you're doing some sort of an audit or for compliance, you will look at the high risk APIs. So all of those different aspects will start becoming important once you start prioritizing and filtering for this data. So the sensitive data that I was explaining earlier, you can also filter by that. So if there are specific user agents, or if there are email addresses or passwords that you are looking for then you can actually query this based on that sensitive data to get a bird's eye view of which of your API endpoints are accessing sensitive data. So that is the key aspect which most of the developers and the security analysts will spend time on from the visibility standpoint. So next, let's look at how this will impact your protection aspects around what kind of threats are lurking in your applications. If there have been breaches, then how does that look like? So threats actually gives you a very good view of that. And here it actually goes by the different users. So one of the key differentiators in Traceable is that we can actually track users as they are going through based on different HTTP sessions, which APIs they're accessing, as well as when we detect attacks or malicious behavior, then we can zoom into it. So now if you look at this view itself, when I look at Anup for a dark web, 44 is the threat score, which obviously tells you that this person has been doing something malicious. So if we now go and zoom into the user's activities, you will start seeing all the different threats which are associated with this user over a period of time, right? So you will see cross-site scripting, you're seeing XSS filter, and then this catches your attention because you're actually seeing the authorization bypass, which is also called as BOLA, which is a broken object level authorization error. So let's zoom into this to see what is actually going on here. So in this view, you can see all the different APIs that the user accessed. So we saw that it starts with NGINX, and then he's actually looking at orders, he's looking at past orders, and right at the very top, you see that the reason why this has been flagged as BOLA is that the particular object ID, in this particular case, does not match with the source, right? So it indicates that this particular user logged in with a certain object ID, and then he manipulated that in the HTTP params in order to try and get data for a different user, right? So this has been a very common attack with a lot of leading web companies where data has been stolen or private information of other users have been accessed by actually using this technique. So that is one of the key aspects that becomes apparent at the very get-go. Now, if we look at the particular attack in more detail, you will see that you can also look at important information around what did the user cookie look like, right? So as you start looking into this information in more detail, you will then be able to figure out how you can add controls for this within the code, or how you can actually start taking actions based on this particular user's use of the application, right? So if you go back, one of the common things you can do is actually take specific action. Now, because we know this particular user is misbehaving or is potentially an attacker, we can actually go and deny access for all the different applications that this particular user will be accessing, right? So that is one easy way by which, as a security analyst, you can ensure that malicious users are not given access. Now, over a period of time, as you start tracking this behavior, and if you then figure out that some of this has to be dealt with differently, then you can also take different actions. So you can also go and resolve security events if it is deemed to be benign. If you look at all of the different options here, you will see that for further analysis, if the SOC analyst feels that, hey, this restricted file access attempt on individual actions that you can take as a security analyst for benign events. Similarly, you can suspend certain users, and if you see that this was anomalous behavior only for a particular period of time, you can give them access back. So there is a lot of control that you have as a security analyst within Traceable. So we looked at the security events earlier, but this graph gives you a very good view of what kind of behavior was there within the application, and you can now search based on different users, right? So if you look at Anup 4, because we looked at it on the threats page as well, you start seeing a pattern here, right? As in there is behavior which is catching your attention because the threat seems to be high here. And then again, it tells you all the different security events which were detected by Traceable. Again, you see the broken object level authorization, you see cross-site scripting. So this immediately gives you a very good view of what the user has been up to, and this periodic nature of malicious activity actually tells you that this is not a regular user. You can similarly look at endpoints, the more sensitive ones. Obviously card checkout is something that you will be more concerned about. If you want to look at specific activity for certain post events, you can start looking at that. So essentially, you get this fine-grained control and view from a security events perspective on over a period of time how your API endpoints have been accessed and what is the threat associated with them. So the last thing I will end on is the vulnerabilities aspect, which again is a very good capability for developers, because now they can see that for these particular endpoints, in certain cases, if the query params contain sensitive data, and then we tell you what is the associated risk. This description clearly tells you that there could be credit card fraud or identity theft or other crimes associated if you have sensitive data in your query parameters, and we also give you the mitigation. Similarly, for encryption, you can do something similar. So this is a very high-level view of the capabilities within Traceable. In this case, this was an application in Kubernetes, front-ended by an NGINX Ingress Controller, and with Traceable and NGINX together, you can get the complete API security in this environment. So now that we went over the demo and looked at all the different pieces which are part of the integration, we are very excited that this is now available to customers. Both NGINX and Traceable customers who are using Kubernetes can take benefit of these capabilities. And as both companies are very nimble, so if you have any feature requests or any feedback or anything that we can add into this, we would love to hear your inputs on that. Damien, if you would like to add something.
Yeah, no, just thanks everyone for joining us today. It was a great conversation with you as usual, Sudeep. And yeah, please reach out if there's any questions or comments. We always love more input on our open source projects and what we're working on. So we really want to know, what problems are people running into? How can we help you guys solve them? I mean, it's there's a lot going on out there now, and we want to help make sure people are successful with their Kubernetes infrastructure.
Thank you. Hope this was a good use of your time, everyone. Thanks for taking your time, and we wish everybody is safe and sound in the interesting times we live in. Thank you again.
And let's see if we have any questions. Q&A portion of the webinar here. So we do have a question. How can NGINX and Traceable help an MSP secure its APIs using interoperability among clouds? That's a heavy one. I want to take a swing at that.
Yeah, I mean, there's definitely a lot that can be done there when you're talking about communication between different endpoints. It really comes down to the specific use case, but yeah, you can have it sitting out, NGINX and Traceable sitting in front of those other endpoints to add whatever layer of security you need wherever it needs to be, right? At the end of the day, using all the different methodologies to add that extra layer of security on top of what maybe is already built into the API. So there's a lot that can be done there, and really just comes down to tailoring it for the specific use case. I don't know, Sudeep, if you have any other thoughts on that sort of integration point. Oh, I think we've lost your audio there, Sudeep.
Yeah, can you guys hear me now?
Yeah.
Yep.
Yeah, no, the only thing I was going to add was, Damien, in case of the multi-cloud scenario, because we can work identically in AWS or GCP or Azure, so far as NGINX plus Traceable is available at the Ingress Controller layer within Kubernetes, we'll be able to provide identical functionality.
Great, thanks. Let's see, there's a question here about how does Traceable learn about all my APIs? Does it require an open API spec? What about the shadow APIs? So kind of two questions there.
Yeah, it was, so for the first one, currently we don't require any API spec. It is all done at runtime. So as we start learning the application, as we start seeing the application flows, we'll have an understanding of all the APIs that are part of the application, and they are accessed by users. With regards to shadow APIs, yes, as in from our standpoint, any API which is accessible, which is part of the application flow, will be visible within the system. So in fact, that's where a lot of our customers find it very useful that once they turn on Traceable, they now have visibility into a bunch of APIs which they never knew existed or which were in the uncommon traversal paths. So we can cover that.
Very good. Here's one for Damien. I think, what's the difference between all the NGINX Ingress controllers out there? Well, that's a big question.
Yeah, there's a lot of confusion around that. Obviously the upstream, or what ships with Kubernetes, is built on NGINX. So we usually refer to that as the upstream Ingress controller, which is built on NGINX open source and maintained by the community. We've also built our own Ingress controller implementation that has those extra virtual server and virtual server route functionalities that we discussed earlier. And that's been added into the official NGINX Inc. Ingress controller that also supports Plus and open source. So it's not something that is only for customers. It also has an open source implementation as well that has that same virtual server and virtual server route functionality, but is missing a few features that Plus does enable you. So it's a lot of that more production grade Ingress controller. So we do get that question a lot, and yeah, it's we're doing a lot of work with the community now as well. So we're helping maintain all of the NGINX Ingress controllers at this point.
That's great, and the community thanks you for that. Looks like we are a little bit over here. I think that's it for questions. So this concludes the webinar with that. Thank you, everyone, for being on the call and joining us. Thank you, Sadiq and Damien, for your presentation and discussion. With that, hope you'll join us again. On screen is a link to Traceable AI's new ebook on API security. Please check it out for a deeper dive on what we need to do more of around security. Once again, thank you for your time and attention. Have a good rest of your day or evening.